Hello there, this is a geometry video. It is chapter 5, section 5, the triangle inequality. And today, obviously, we're going to be talking about the triangle inequality theorem. But before I get to the actual theorem, I want to show you a hands-on kind of thing here of what's going on with the triangle inequality theorem. Most people think that just because you have three sides, three different lengths, that you automatically can put those three lengths together and make a triangle. And the triangle inequality theorem is basically here to show us that that is always the case. There have to be some parameters of that to happen. So what I have done is I have randomly, well not really randomly, but I have selected three lengths and I have measured them out, and they are 3 centimeters, 6 centimeters, and 10 centimeters. And so I am with this yarn, and I hope that you can see that in the video. And I am going to tape these to the board so you can kind of see. I'm basically taking these three lengths and I'm trying to make a triangle. So I am going to put my yarn corners together. Hopefully this tape will stick. And I'm going to hope that it makes a triangle. Doesn't seem too complicated. You just put out the lengths and hope for the best, I guess. But you will see in a few seconds here that a triangle is not always possible when you don't have the right combination of lengths. And here is my case in point. I have my length of 3, my length of 10, and this middle length is the length of 6. And it doesn't really matter what I do to try to stretch it out. It is not going to reach the other end point of the bottom segment in order to make a nice triangle. I can obviously bring this segment down here to where it touches and make a triangle there, but clearly I cannot have a triangle with the lengths 3, 6, and 10. And so that's what I wanted to demonstrate here, is that this triangle is basically left incomplete. And so we realize that we do have to have a relationship between the lengths of the sides in order for the triangle to actually work. And that is exactly what this theorem says. Now I really hope that you can just ignore the tape for now, because I'm going to need to use this in a second as I give you an example. But, or actually I'll just take it off. It doesn't seem like it's going to let you view things very well, but hopefully that served its purpose and you can see with your eyeballs why it doesn't work. But here we have our triangle inequality theorem. Basically what it states is that the sum of the lengths of any two sides of the triangle taken together must be greater than the length of the third side. So in a nutshell, what that means is that you can basically come up with 3 separate inequalities, because there's 3 sides, and so we can group 2 sides together at a time 3 different ways. So I have basically taken and color coded here a little bit, but you've got side PQ and QR combined have to be larger than PR, but also you could combine QR and PR, the blue and the green, and it has to be greater than the red, which is PQ. Or you can combine the green and the red, which is PR and PQ, and they should be greater than QR. Those 3 things have to happen in order for the triangle to work. And so what happened in our example is that when I take 3 and 6, or 6 and 10, or 3 and 10, so I have my 3 different options. 3 plus 6 should be larger than 10. 6 plus 10 should be larger than 3, and 3 plus 10 should be larger than 6. And here we get 9 is larger than 10, which is not true. And then here we have 16 is bigger than 3, which is very true. And 13 bigger than 6, which is also true. But because one of the inequalities failed, then the triangle doesn't exist. So here we have our first example, and it says, is it possible to form a triangle with the given side lengths? And if not, explain why not. And so the easiest thing for us to do is to basically set up those 3 inequalities. So in this case, I can take 8 and 15, and that should be larger than 17. 15 and 17 should be larger than 8. And then lastly, 8 and 17 should be larger than 15. Now, if all of these hold true, then we're in good shape. And 8 plus 15 is going to be 23, and 23 is larger than 17, so that's true. 15 plus 17 is going to be 32, and 32 is larger than 8, so that's going to hold true. And then 8 plus 17 is going to be 25, and 25 is larger than 15. So because all of the inequalities are true in this case, then it means that this triangle, or these side lengths, will form a triangle. So yes, it is possible in that case. But what about the second case in part B? We know that 6 and 8 should be larger than 14. 8 and 14 larger than 6. And 6 and 14 larger than 8. So 6 plus 8 is going to give us 14 larger than 14. And no, 14 is not larger than itself. 14 is equal to itself. So even though that's cutting it close, that's false. 8 plus 14 is going to be 22, which is larger than 6. And 6 and 14 is 20, which is larger than 8. So that's true. But because 6 plus 8 is not larger than 14, the answer here is no. These side lengths will not form a triangle. And when we explain why not, we simply say that 6 plus 8 is not larger than 14. So we use our algebra to explain why it doesn't work. So now you can try this do-it-yourself example, and then we'll move on to another application of the triangle inequality theorem. Okay, so this one says, if the measures of two sides of the triangle are given, so they're given to be 3 feet and 7 feet, then what are the possible whole number measures for the third side? That might sound weird to you, but basically what's happening is that when the lengths of two sides of a triangle are known, like we know the 3 feet and the 7 feet, then the third side can be any length within a range of values. So what they're basically asking us for is that range of values. And we can use the triangle inequality theorem to determine what that range of possible lengths is for the third side. So we know the easiest way to do this is to basically, oops, my bad. We want to come up with, why do I keep doing that? 3 measures. So we have 3, 7, and then we don't know the third side, so we'll just call it x. And we're still going to set up our 3 inequalities. We're going to say 3 plus 7, so these two sides should be larger than x. 7 plus x should be larger than 3. And then 3 plus x should be larger than 7. So the only difference now is that we don't actually know what the x variable is. So all we do is we take these 3 inequalities and we solve for x. So in this case it says 3 plus 7, so 10 is bigger than x, and then that's pretty much done. We don't usually look at it that way. If 10 is bigger than x, it means that x is smaller than 10. In this case we subtract 7, and this will always happen. You will always end up with one of the 3 inequalities that will give you a negative answer. Basically a throwaway. So this is a throwaway, and that's okay, that's normal. And then the last one we get that x has to be greater than 4. So basically our range of values that we're looking for here is that x needs to be larger than 4, but at the same time smaller than 10. As long as you pick a number between 4 and 10 for the third side, then the triangle will exist. So our possible whole number measures are going to be that x is less than 10 but bigger than 4, and there's your possible whole number measures for the third side, somewhere between 4 and 10. It is important that you show your work all the time, that you show all 3 inequalities. I don't care if one of them is always going to be a throwaway. If you want full credit on your quizzes and your tests, you need to make sure that when you do the problem that you show me all 3 inequalities, and that goes for example 1 as well. So now you can do yourself number 2. They are giving you 2 measures, 13 and 9, and are asking for the possible range of values for n, which is the third side that's not given. All right, so now we go to our last application. And in case this looks funky, this is supposed to be an L. But in the book, you basically have a whole storyline about flights, and Colorado's over here, and we've got Lincoln, Nebraska up here, we've got Tulsa, Oklahoma down here, and we have Abilene, Texas down here. So basically what the problem is telling us is that the distance between Colorado Springs and Texas, Abilene, Texas, so this segment here, is the same as the distance from Colorado Springs to Oklahoma. So we know that these two are congruent, which is why it says CA equals CT. I only gave you the raw bones of what we needed to know in order to do the proof. But basically it wants us to prove that a direct flight from Colorado Springs to Tulsa through Lincoln, Nebraska. So basically they're saying if I go from Colorado to Lincoln, Nebraska, and then to Tulsa, will that be, that distance will be greater than a nonstop flight that just goes straight from Colorado Springs to Abilene, Texas. Okay, so they want us to prove that going from CL and LT, that distance is larger than going straight from C to A, even though we know these two are the same. So the proof is actually fairly simple, and we're going to get started over here. First and foremost, I already have our given statements, CA equals CT. And then in number two, what we're going to do is we're going to use the triangle inequality theorem to state that CL plus LT is greater than, so remember we have that the two sides, the sum of the two sides should be greater than the third side, and the third side is CT. So by the triangle inequality theorem, we know that CL plus LT is greater than CT. Now you think that you're done, right? You're awfully close, but this doesn't say CT, it says CA. Okay, but we can use step one, where we know that CA and CT are equivalent, and we can substitute CT with CA because they're equal. So in our third step, we just say CL plus LT is greater than CA by substitution, and there you're it. That's it, a three-step proof. Substitution, don't forget your Helmholtz, and that proof is done. So not a very complicated proof. And so now we want you to write this two-column proof. It's very similar. And then once you have done that, you will have completed your notes for this lesson. And I will see you in class. And thanks for watching.